Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to the questions in paper 1 of the 2013 JEE Advanced Physics paper. The order I'll be following will be the same as in code 0, but in any other order the questions will be the same, just the order will be different, so you can figure that out for yourself. So let's do a particle of mass m is projected from the ground with an initial speed u0, a standard projectile, and at the highest point it makes an inelastic collision with another particle thrown upwards with the same initial speed u0. Okay, so first we have a standard projectile, u at an angle theta, going like this, and then when it is at a highest point it hits an other particle which was thrown upward with the same initial speed u0. So there was another particle thrown upwards with the speed u0, and by the time it reaches here, this particle is here as well. So they are both here at the same time. So the first thing we need to see is this starts with the speed u0, but this starts with the speed u0 sine theta in the vertical direction. But they both travel the same distance, this distance, so obviously they started at different times. The initial time, the time at which this was projected, was not the time at which this was thrown up. That's the biggest mistake students might make. They might assume they were both thrown upwards simultaneously, but that's not true. So we can calculate this u0 in terms of the other variables. What is this? This is the maximum height, which is u square sine square theta. In the question they've taken alpha, but I'm used to taking theta, so let me just take that and we'll just replace that at the end. U square sine square theta by 2g. Right, this is this height. So we know if we want to find out the vertical component of this velocity when it reaches here, v, we know that v square will be u square minus 2gh. Right, that's the beauty of this third equation. This third equation, v square is equal to u square plus 2ah, does not have time in it, so you don't need to worry about times. H will be u square sine square theta by 2g. G2g cancels. U square minus u square sine square theta is u square cos square theta, which means that v is equal to u cos theta. Right, it can be minus u cos theta as well. That will mean it's coming down with the same speed, but we are given that it is hit when it is thrown upwards. Right, so at this point this has a speed upwards equal to u cos theta, and this particle has a speed in the horizontal direction is equal to u cos theta. So we don't, and they both have the same mass, so we don't really need to worry about the specifics of the case. Now the question just becomes one particle going here with the speed u cos theta, the other particle going here with the speed u cos theta. They make an inelastic collision. Obviously everything is symmetric about this axis, so they'll be going in this direction. With what speed is of really no concern to us right now. We know that it has to be in this direction, and this angle is 45 degrees. Right, so the answer will be 45 degrees or pi by 4, which is A. If this was u cos theta and this was, let's say, 3u cos theta or 2u sin theta or something, then we would actually have to calculate and solve the equation. But it turns out that both of them ended up being the same, and from that we can easily say that it's around 45 degrees. There is no reason for it to go anywhere else. Right, the sum of this vector p and this vector p will always be in this direction, and since the mass and the speed are the same, they both have the same momentum. Okay. So this completes the solutions for paper 1 of the 2013 JEE Advanced. Fourth question. Thank you.